Welcome. Hello, my name is Hendrik, and this is a video of the series EWM Meets Automation, a video series where I explain different topics, functionalities in the area of SAP EWM MFS. So we are talking about integrating automation with SAP EWM. With this video, I would like to explain the role of the PLC. So that means we will be talking about the components of a PLC, and we will be talking about the main purpose of those components. We will not tackle EWM as such that much. We will talk about the communication between EWM and the PLC, at least on a high level. But for the details, we will release additional videos within the next months where we really talk about how, step by step, the EWM communicates with the PLC and the other way around. So for this video, we will start with the main components. I will explain the different components of the hardware, and then in the second part, we will look at different applications in the context of EWM projects and warehouse automation. So for the beginning, we will concentrate on the inputs, the CPU and the outputs. I will explain step by step, give you some examples, show you some pictures with the objective that after the next 20 minutes, you at least have a high-level understanding of what you are talking about when you are talking about integrating hardware via a PLC into EWM. That's the purpose of this video, just a high-level understanding for everybody who's involved in projects where you are automating intralogistics processes with EWM. As an introduction, let us look at the layer model from the VDI. And this layer model shows you the different systems which are involved in case you want to automate intralogistics processes. So on the highest level, you might have like SAP S/4HANA as an ERP system handling the inventory, so handling deliveries and handling the quantities of stock, then communicating with the warehouse management system, which might be EWM, which is handling the stock on bin level and creating tasks and tracking movements from bin A to bin B. And then we have this material flow control level, which is converting tasks into a format that can be handled by subsystems. And this MFC level might be integrated into the WMS as we have it with EWM, and it might be a separate system. And then we have the level of real-time controllers, so the PLCs, which are then communicating with the sensors and the drives, so the lowest level in terms of hardware. So here we are on the hardware level, and this hardware level is communicating with the WMS and the MFC via telegrams. We will see, we will look into detail here within the next video. But for today, we basically concentrate on the real-time controllers, on the PLCs, and how they interact with the lower and the higher level here. Having said that, you will see that on some of the pictures also. This video is being created together with the experts from Swisslog. So thanks a lot at this point. We have the options to talk to the experts from the controls teams here, and we'll see some pictures of the Swisslog hardware, and we got a lot of input. So thanks for that to the EWM team at Swisslog and also to the controls team at Swisslog who are supporting this video series here. So what you see here is a control cabinet of like for a PLC, which is nothing else than an industrial computer, you can say it like that. And the different components are usually installed on such racks here, within those cabinets. You will see them in industrial areas where automation takes place, being at a warehouse or some production area or whatever. So in such a cabinet, you usually have the PLC, and the first main component we want to talk about is the input. So a PLC receive digital analog signals from different sources, and the most common ones within intralogistics processes are probably like switches or sensors. These are small laser sensors. Conveyors, you will see some pictures later. Or, for example, the input received from scanners or light barriers or things like this. And those inputs like go via bus systems or Ethernet networks and reach the PLC or reach the CPU later. You will see it in the next step via those input modules. And the signals coming from the lower levels are converted into digital bits here, so that these digital bits then can be processed by the CPU. And the CPU is, let's say, the heart of the PLC. It is receiving the inputs from the hardware level, as I explained before, and it receives, or it can receive, input from other systems like EWM, for instance, in form of a telegram. So telegrams, like communicated via TCP/IP to the CPU, also provide information in a digital format, and the CPU itself is processing this data. There is a memory in the CPU which holds the program logic, and based on the program logic, the input is being processed. Here you see the picture of an example of a CPU. Here it's one from Beckhoff, and this holds the main components which are then responsible to process the inputs. Then there might be middleware in between a system like EWM, which sends telegrams to the exchanges telegrams with the CPU, with the PLC here. For example, in order to convert from RFC to TCP/IP based communication, or in order to distribute telegrams among different PLCs on the subsystem level, and so on. So that's what I mentioned before, and that's what you saw on the rack, in the cabinet already, the CPU, which is connected with the inputs, and which is the heart of the PLC holding the program, and the coding actually, which is processing the input. And this is one example. So usually, if we go back one more time, as I said, there's a memory. The program logic is then downloaded to the PLC, to the memory. So it's written in an application. So in the same way, like you write a program in a programming environment for SAP, for instance, in the workbench, in the same way, you have an application where the program logic for the PLC is being written. And this example screenshots here show this the TIA portal from Siemens, which is one of the most popular applications to write such programs. And you have the option, you see it here, you have the option to use like simple operators like AND, or like connect two inputs from two different sensors and then make an AND connection. And then if you have both sensors on high, then the AND connection is true, and then you trigger a follow-up process based on this. But you can also have complex coding in the same way, like you have coding in ABAP or any other programming language. You can take the input from the lower levels, or from data received via telegram from the WMS, for instance. Take the input and process it using variables in the same way like you're using variables in ABAP coding, and process it and then trigger a follow-up action based on this. Having said that, follow-up action also means the CPU also has an output. And the same way as it has an input from EWM or from the sensor level, it has an output. So it could, for instance, set output signals to high. So basically, like converting the digital information, which is a result of the program logic, into an electrical signal, which is sent to an output. So it could, for instance, be the activation of an engine for a conveyor, or the activation of a scanner, that it starts reading. And on the other end, it could be a telegram which is created and sent to EWM. For example, at the I point, where data is collected for an object, then a telegram for the identification is created and passed and sent to EWM. And as I said before, input and output modules can be connected to the CPU via bus systems, like you use them in industrial environments, or normal Ethernet computer networks. That's both possible. Good, so in summary, I don't want to make it too complex here, and I'm pretty sure I missed a lot of details, but I'm also sure that you don't need all those details in order to have a high-level understanding. So the objective here is to give you exactly that understanding that you need in order to let's say, survive EWM projects and like have a level of understanding so that you can talk with the controls team and that you also understand the processes end to end. Actually, what happens if a pallet arrives at the I point on the conveyor, and how does actually EWM receive the data and all this stuff. So that's the first level of understanding here. We will go deeper with the next videos. But as a summary for now, the PLC receives an input, like from EWM or from a scanner or from a sensor or from a scale, whatever, then performs the logic based on the input and based on the program which is sitting in the memory of the CPU here, and which is written in an application on a computer and then downloaded to the CPU. And then this combination, like the problem logic and the inputs, might trigger an output based on the result of the logic. And the output, again, might be an electrical signal, which is triggering some physical action, or it might be a telegram sent to EWM as an overlaying system. So what is the role in the context of EWM projects? So let us become a bit practical here, so that you can transfer this theoretical knowledge now into the practical world. So we start with some examples for pure PLC logic, so nothing to do with EWM, and then we look at a couple of examples where PLC interacts, communicates with EWM. First one, pretty easy one. The PLC monitors the sensors and reads the result of a scanner. So on this picture here, you see sensors here, the small blue ones. You see this red laser beam, and then you see a scanner. And in this simple example here, if this sensor here detects an object, the PLC receives the signals from those sensors and then sends an output signal to the scanner to scan. Yeah? So we have input to the PLC, we have problem logic, okay, if this sensor is high, then please activate the scanner. So output for the scanner, electrical signal, scanner, please start reading. First very simple example. And then we have another simple example here on the conveyor. You also see here, this arrow shows this small sensor. You see here this red laser beam, a light barrier, and if this one detects something, the PLC knows, okay, there's an object sitting on this conveyor segment, and based on this information, it might start the conveyor drive, the engine that starts the rolls here, so the object moves onto the next part of the conveyor. Similar example here for a pallet conveyor, where we have here the sensor, light barrier, recognizing an object sitting here, then starting, PLC maybe starting at conveyor, move the pallet towards the I point here. Next example is simply like tracking of HUs. So when you are in a warehouse where you have a conveyor or case or pallet conveyor, you will see those sensors sitting in many places, and the PLC just keeps track where the objects are currently at. So when it leaves a specific segment or arrives on another segment. One more example, and now we are jumping into the ones where the PLC communicates with EWM. So the first example here is the tunnel check. So you know a pallet has feet, and in the middle you have these tunnel checks. So that just makes sure that the pallet has the accurate quality in order to be stored and handled by cranes, for instance. And for this purpose, you usually see on pallet conveyors these tunnel check elements. So if there's some wood not neatly aligned, it will kick these tunnel checkers here, and they will send a signal to the PLC telling the PLC that the pallet is not in an accurate condition. And based on this information, the PLC sends a telegram to EWM and says, hey, this is a pallet which is not in an accurate condition. Where do you want to send it? And then EWM decides, okay, my clearing or reject station is communication point XYZ, and sends this information to the PLC so that the PLC knows where to send the pallet. Just another simple example here. One more is this one are pictures of identification points. Here for a pallet and here for a case. We are basically measuring the dimensions and the height and the length and the width. So the subsystem collects those information. The PLC summarizes all the information that it receives from the different sensors and light barriers and scales, for instance, and then collects this information telegram, which is then sent to EWM, and EWM can decide how to handle the result or how to interpret this information and trigger a follow-up task with the destination based on the checks at the eye point. Last example here, also an example that most of you might know from your projects. So EWM creates a task for stock removal from an automated high bay. So in order to process this task, needs to send a telegram to the PLC. So PLC receives a telegram which contains the information to remove the pallet X from bin Y. So PLC interprets this data in a way that it knows where to move the crane and from which bin to remove the object in order to place the pallet then on the deposit bin of the given ale so that it arrives at its destination. So in this example, it's simply a task being sent from EWM to the PLC in the format of a telegram. And as I said before, the detailed communication flow, like how does the telegram actually flow from EWM to the PLC, how does the logic look like step by step, that will be tackled within the following months, within the next videos in this series here. For now, that should be enough to give you a high-level understanding. And that is the last example that I wanted to give here for the intralogistics context where the PLCs are being used. We are at a point where I would like to give you a summary of what the PLC does in the context of warehouse automation, so that you have this connection to the practical world. And there are some more, but I think we can narrow it down to the monitoring of sensors. This is just to identify HUs and to track the HUs on the automation. Then the control of drives for conveyors and for cranes or all other kinds of equipment like transfer cars or empty pallet stackers or whatever. So it switches on or off those drives, and to read the result of scanners. There's probably no warehouse automation without any scanners reading barcode, matrix code, whatever. And this interaction with the physics, the PLC, the CPU, it interacts with the physics, and the result of this interaction is then input on output, input of a pure PLC logic on output from the PLC logic. So what the scanner reads is an input to a PLC logic, and if the PLC starts a conveyor drive, it's an output of a PLC logic. So it's either a pure PLC logic, or it's a logic which resides partly or fully within an WMS like EWM. So within such automated warehouses, you will find a lot of decisions which the PLC does on its own. But as I said, we have those Telegram communication, which supports those kind of decisions where the PLC as well as EWM decides what to do and how to process data. And the latter is done via this Telegram communication. Good. That should be it for today's video. As I said, in terms of Outlook, we will look at the integration between EWM and the PLC. With this video, we will tackle the most important objects which are used to connect, like, let's say, core EWM with EWM MFS, but also EWM MFS with the PLC layer. And today, we only looked at what the PLC is actually doing. And in the next video, we will look at how it really integrates with EWM. And then with the next videos, we will specify this and go into detail here and really try to understand how the communication flow looks like step by step, EWM to PLC and the other way around. Having said that, I would really appreciate if you subscribe to the channel. You benefit from the fact that you will be notified when we release those new videos. And if you need more information in terms of warehouse automation along with EWM, you need support within your projects, please feel free to get in touch with the EWM team at Swisslog. I will put some links in the video description so you can reach their website and reach out to them, and they will be happy to support you in your project. Good, that should be it for today. I hope you could learn something, and I hope to see you again in the next video. Goodbye.